The Space Power, which is written by Dr. K. Sivan and the ISRO team. So, the beginning of the Indian space program resonated strongly with its founding father, Dr. Vikram Sarabhai's vision that must be second to none in the application of advanced technologies for the benefit of the society. It was with the formation of Indian National Committee for Space Research in COSPAR in 1962, followed by the first sounding rocket launch from Tumba Equatorial Rocket Launching Station in 1963, that was the space program formally took off. Dr. Sarabhai, the architect of the Indian space program, initiated the creation of dedicated clusters. So, while Trivandrum became the hub for the sounding rockets, solid propellants, etc., with the setting up of Space Science and Technology Center, the cornerstone for payload development and related electronics was at Ahmedabad in the form of Experimental Satellite Communication Earth Station. The Indian Space Research Organization was formed in 1969, superseding INCOSPAR, which is formed in the year 1962. Today, with a total workforce of over 18,000, ISRO's establishments are functioning in many parts of the country, with each concentrating on a specific specialized domain. The country's public as well as private sector industries are playing a crucial role in our space program. Besides, various academic institutions have also contributed to the Indian space endeavor. With the establishment of the Space Commission and Department of Space in 1972, ISRO was brought under Department of Space, and structured space program was now poised to soar under the leadership of Dr. Satish Dhawan. The 70s were the learning phase during several experimental satellites were built, including India's first satellite Aryabhatta, which was launched on 19th April 1975 from a launch center in the former Soviet Union. Aryabhatta laid a firm foundation for the later immensely successful Indian satellite program. Bhaskara 1 and 2, the two experimental Earth observation satellites, provided the rich experience and confidence to build complex operational remote sensing satellites. Today, India is world leader in satellite based remote sensing area. Additionally, Apple means Ariane Passenger Payload Experiment, India's first experimental communication satellite, although launched by the European Ariane rocket, reached its final geosynchronous orbital home in June 1981 with the help of rocket motor developed in India. Aryabhatta and the two Bhaskaras, as well as Apple, were launched free of cost, which reflects the India's successful international space cooperation policy. In the recent past, India has not only flown foreign scientific instruments on board Indian spacecrafts but has also launched them. Two further significant satellite communication experiments that deserve a mention here for their ingenuity and spirit of cooperation are Satellite Instructional Television Experiment site from on 1975 to 76 and Satellite Telecommunication Experimental Project STEP 1977 to 79 comprehensively establishing the usage of satellites for communication and broadcasting and providing hands-on experience for the same, paving the way for Indian National Satellite series of satellites. In the space transformation domain, it was commissioning the Satellite Launch Vehicle 3 SLV-3 project in the early 1970s, the first indigenous experimental satellite launch vehicle that served as the beginning of an enduring partnership between ISRO and Indian industries. And all solid four stage launch vehicle, the SLV 3, was designed for placing satellites weighing 40 kgs in low Earth orbit. The SLV 3 had its successful launch on 18th July 1980, thrusting India on into the select league of six countries which with the capability to launch satellites on their own. On the heels of SLV-3 was commissioned the ASLV, that is Augmented Satellite Launch Vehicle project in the early 1980s. The next step of evolution is launch vehicle technology. The two launch vehicles, that is SLV 3 and ASLV, validated the critical launch vehicle technologies and gave ISRO the confidence to reach the next level with the Polar Satellite Launch Vehicle project, commissioned in the mid 1980s. During the same period, INSAT's 1B, India's first multi-purpose operational satellite, was launched in 1983, demonstrating its ability to bring about a rapid and major revolution in India's telecommunication, television broadcasting, and weather forecasting domains. India's ability to design, build, and maintain a complex remote sensing satellite was demonstrated in 1988 when IRS 1A, the first operational satellite built in India, started imaging the Earth. The images sent by the Earth circling the Earth from the 900-kilometer high polar orbit was utilized in various diverse fields such as agriculture, groundwater prospecting, mineral survey, forestry, etc. During the 1900s, ISRO began building INSAT 2 series of multi-purpose satellites indigenously. At the time, systematic usage of imagery from our remote sensing satellites for tasks like crop yield estimation, groundwater and mineral prospecting, forest survey, urban sprawl monitoring, and wasteland classification and fisheries development began. The optimal use of onboard capabilities of INSAT and remote sensing satellites was coordinated using interministerial mechanisms such as INSAT Coordination Committee ICC and National Natural Resource Management System NNRMS. Today, India has a fleet of advanced remote sensing satellites equipped with high resolution and multispectral cameras dedicated to the theme of cartography, resource survey, and ocean and atmospheric applications. The INSAT system, with over 300 transponders in the C band, extended C band, Ku band, Ka or Ku band, and S band, provides services to telecommunication, television broadcasting, radio networking, satellite news gathering, societal applications, weather forecasting, disaster management, and search and rescue operations. High throughput satellites, that is HTS, such as GSAT 11, GSAT 29, and GSAT 19, are supporting the Digital India campaigns by boosting the broadband connectivity to the rural and inaccessible gram panchayats in the country. The transponders on these satellites will bridge the digital divide for users, including those in Jammu and Kashmir and northeastern regions of India. The space transportation domain, with successful advent of the Polar Satellite Launch Vehicle PSLV in 1994, witnessed a quantum jump in the indigenous launch capabilities. The vehicle has proven to be the workhorse of ISRO, logging over 50 successful missions, launching national as well as foreign satellites. On 15th February 2017, PSLV created a world record by successfully placing 104 satellites in the orbit during the single launch. Well, as the numbers go, it was undoubtedly a record at the time, which was significance which was at the time, but the real significance of the achievement is the immense confidence reposed by the foreign countries in the capability of the launch vehicle. With the solid and liquid propulsion technologies perfected through SLV 3, ASLV, and PSLV, the nation embarked upon a highly challenging question to master the complex cryogenic technology. The commissioning of the Geosynchronous Satellite Launch Vehicle GSLV in 1990s was step in this direction. The launch vehicle was designed in three stages, including the cryogenic upper stage, the four liquid strap-ons. So the cryogenic technology involves the storage of liquid hydrogen and liquid oxygen at very low temperatures. Materials used to operate these At these very low temperatures, chilling processes and interplay of engine parameters make the development of cryogenic stage a very challenging and complex task. With the successful qualifications of the indigenously developed cryogenic upper stage in the GSLV D5 flight on January 5th, 2014, ISRO demonstrated its mastery on cryogenic rocket propulsion. Including the one in January 2014, the vehicle has had 6 successful flights over the past decade. The next generation launch vehicle of ISRO, with the capability of putting 40 payload in GTO, came in the form of GSLV Mk3, designed with the two solid strap-ons, a core liquid booster, and a cryogenic upper stage. LVM3X CARE mission, the first operational suborbital flight of GSLV Mk3, was on 18th December 2014 and launched the crew module atmospheric re-entry experiment, that is CARE. The CARE module began its return journey and a little later re-entered the Earth's atmosphere. It was successfully recovered over the Bay of Bengal about 20 minutes after its launch. Subsequently, after two successful developmental flights and with the injection of Chandrayaan 2 into the Earth's parking orbit in July 2019, GSLV Mk3 successfully entered its operational phase. Indian space program has always focused on the development and utilization of space technologies to achieve the overall development of the country. Despite its emphasis on application, ISRO has pursued many space science projects to perform meaningful exploration of space. India's first satellite Aryabhatta was the scientific satellite. After Aryabhatta, ISRO entered into the realm of science missions again with a unique mission, the Space Capsule Recovery Experiment, launched by PSLV in January 2007. SRE 1, with its scientific experiments, orbited the Earth for 12 days and was successfully deorbited and recovered over Bay of Bengal. This proved several technologies necessary for reusable launch vehicles and human spaceflight. The space science missions of India, Chandrayaan 1, Mars Orbiter mission, Astrosat, and Chandrayaan 2, have caught the attention of millions of Indians as well as outside world. Launched by PSLV on 22nd October 2008, the 1380 kgs Chandrayaan 1 spacecraft was successfully navigated to the moon in 3 weeks and was put into an orbit around the moon. On 14th November 2008, when the TV set sized moon impact probes separated from Chandrayaan 1 spacecraft and successfully impacted the surface of the moon, India became the fourth country to send a probe to the lunar surface after the United States and the Soviet Union and Japan. Later, when Chandrayaan 1 conclusively discovered water molecules on the lunar surface, it was widely hailed as a path breaking discovery. Uplifted by the success of Chandrayaan 1, ISRO embarked on the Mars Orbiter mission for demonstrating India's capability to build, launch, and navigate an unmanned spacecraft to Mars. Launched by PSLV on 5th November 2013, the 1340 kg Mars Orbiter spacecraft encountered Mars on 24th September 2014. With this, ISRO has become the fourth space agency to successfully send a spacecraft to Mars orbit. Astrosat, launched by PSLV in September 2015, is the first dedicated Indian astronomy mission aimed at studying the celestial sources in X-ray, optical, and UV spectral bands simultaneously. Astrosat recently made a major breakthrough by discovering one of the earliest galaxies in the extreme ultraviolet light. The Chandrayaan 2 mission, India's second mission to the moon, was successfully launched on 22nd July 2019. Chandrayaan 2 orbiter spacecraft was placed in its intended orbit. The 8 instruments on board The orbiter are continuously providing useful science data which will enrich our understanding of the moon's evolution and mapping of minerals and water molecules in polar regions. ISRO has also successfully established and operationalized navigation with Indian Celeste constellation NAVIC, which provides highly accurate position, navigation, and timely information to users in India and its surroundings. The Global Standards Body Third Generation Partnership Program, which develops protocols for mobile telephony, has approved NAVIC, and major mobile chipset manufacturers have incorporated NAVIC in their releases. Further, through GPS aided GEO, that is augmented navigation (GAGAN), ISRO is providing satellite based navigation services with accuracy and integrity required for civil aviation applications to provide better air traffic management over Indian spacecraft. In the recent past, Gaganyaan program approved by the government of India in 2018 marks a point of inflection in the Indian space journey, making its entry into the new age of human space exploration. The Human Space Flight Center HSFC was constituted in ISRO in January 2019 for implementing the vision on the human spaceflight program. HSFC is entrusted to implement Gaganyaan program and to act as a lead center for sustained and affordable human spaceflight activities. The Gaganyaan project was the stated objective of demonstrating human spaceflight capabilities to low Earth orbit for a defined duration and safe recovery after the mission. ISRO successfully proved a crucial technology element of human spaceflight in July 2018, the Pad Abort Test (PAT), which is the first in the series of tests to qualify the Crew Escape System (CES). The Pad Abort test flight was a demonstration of the capability of CES. CES means Crew Escape System to evacuate the crew in the case of contingency at this launch pad. Towards capacity building in human resources and to meet the growing demands of Indian space program, the Indian Institute of Space Science and Technology, a deemed university, was established at Thiruvananthapuram in 2007. The institute offers bachelor's degree in space technology with specialization in aerospace engineering and electronics and communication, and the master's program in the areas of space technology. Further, amidst the COVID 19 pandemic, the landmark space reforms initiated by the Government of India in June 2020 mark a significant step towards forwarding in the evolution of the Indian space economy. The creation of the Indian National Space Promotion and Authorization Center in Space to promote handhold and authorize non government private entities to undertake space activities shall unleash the next wave of advancement in the sector. This will enhance the diffusion of space technology and boost the space economy within the country. Empowering the department PSU, New Space India Limited (NSIL) to own the operational launch vehicles and the space assets of ISRO opens up a new chapter in the management of space activities in the country. Further, the present supply based model was changed to a deemed demand model, wherein NSIL shall act as an aggregator of users' requirements and simultaneously obtain commitments. With these structural adjustments, ISRO shall focus on advancing the research and development endeavors such as heavier and more efficient satellites, advanced space missions such as Chandrayaan 3, Aditya L1, and mission to Venus to further explore the solar system, and, of course, the Gaganyaan program. The future of space activities in the country looks very promising indeed and shall cement India's position as a 21st century space power.